So the next one here is what do we have? It says a curve C has equation y equals x cubed minus 2x squared minus x plus 9, where x is greater than 0. It says the point P has coordinates 2, 7. And it says show that P lies on C. So it's only one mark, right? Now, to show that a point lies on C, right? Well, what does it mean when you have a curve and you have a point that lies on it or that passes through? It means that the value of x and y must be satisfied by this equation here. Yeah. So all you're going to be doing is plugging in x equals 2, and you should expect to get 7 out, right? Because that's what it means if it lies on C. So you have y is equal to uh 2 cubed minus 2 lots of 2 squared minus 2 plus 9. And then what's this? This is, you can put this in your calculator, by about 8. And then this is 4, this is 8 again. Minus 2 plus 9. 8 minus 8 is 0. Minus 2 plus 9 is 7, right? And all you have to say now is therefore P lies on C, right? Now, what I did see in one of your answers, right, is that one of you said that this was a minimum point, right? Now, you did do the same thing, but you said it's a minimum point. It doesn't say anything about it being a minimum point, right? It's just a point P. So you don't have to write it's a minimum or anything like that. Does that make sense for this one? It's all okay. We just plug it in x equals 2 and we're getting 7 out. So it shows that it lies on C. Yeah? Okay. So continuing. For 5 marks, it says find an equation of the tangent to C at P, given your answer in the form y equals mx plus c, where m and c are constants. Yeah? Now, this one, guys, what are our thoughts on this one? It's 5 marks. I'm just going to double check to see what we got for this one, by the way. But can somebody tell me, please, in the meantime, how would I go about doing this? Just having a look here. Just going to try and edit this 1 second. Okay, so I can see a couple of answers here. Okay. Now, the key word I can see here, guys, is tangent, right? It's tangent. Remember when we did this a couple of weeks ago? When did we do it? Differentiation. What did we title this? Gradients, tangents, and normals. Remember this formula here? The tangent to a curve, right? At the point P with coordinates A, f of A has this formula here. Another way of writing it is like this here, right? So what you need to do, let me write this here. We've got this. So if you want to find the equation of a tangent, you're going to use y minus y1 is equal to mx minus x1, right? Where x1 and y1 is your point, right? That you're looking at. And m is the gradient of the tangent. Does this all make sense, guys? Does this all ring a bell? If everyone to just say yes or no, so I know we're all okay. Do we remember this when we did this a couple weeks back? Yeah. So what do we have? Well, remember the point P was 2, 7. They told us that in part A. Yeah. So the point P is 2, 7. So I know my x1 and y1 already. So now I could just say, if I were to just fill out this formula, it's going to be y minus 7, right, is equal to m and then x minus 2. This is our answer so far. Now, what we need to find is m, which we know is the gradient of the tangent. Can somebody tell me, please, how do I find the gradient of a tangent? Let me get the graph. Let me get the function again here, right? We need to find the gradient of a tangent. Anybody know how we do that? Or remember, guys, whenever you're finding the gradient of a tangent, right, you need to differentiate. Remember, tangent is a key word, right? To find the gradient of a tangent, let's just go back to when we did it here. Remember, we did this a couple of weeks back. I think we did it for one of the final answers here. Can you see? Find the equation of a tangent, gradient. How do you find the gradient? You differentiate, right? Remember, we did this a couple of weeks ago. So all you had to do here is differentiate your function, right? So if we differentiate this, we're going to have dy dx is equal to, this drops 3x squared. This is going to be minus 4x, right? That 2 goes to the front, and then we drop it by 1. And then minus x will differentiate to become minus 1, right? And then the 9 will just be 0. So this here is your gradient formula. Does that make sense, guys? Remember, to find the tangent, normal, if you're looking for the gradient in A-level maths, you have to differentiate. Does that make sense? Yeah? Cool. So now continuing, we need to find the gradient at this point, 2, 7. Now, because the formula for the gradient, right, I'll just write gradient here, is in terms of x only, all you need to do is plug in x is equal to 2. Plug in x is equal to 2, right? So if I plug this in here, it's going to be 3 lots of 2 squared minus 4 lots of 2 minus 1. So therefore, this is going to be 2 squared is 4. 4 times 3 is 12. This is minus 8. This is minus 1. So therefore, this is 12 minus 8, which is 4. 4 minus 1 is 3. So therefore, the gradient of the tangent at the point P, which was 2, 7, right, is m is equal to 3. Does that make sense, guys? Yeah, all okay with this? Okay, cool. So I can't see any messages, so I'm assuming this is all okay. So now we're done. Yeah, I keep on running out of room. Let me do this here. So what do we know now? Remember the formula was m. Let me write the formula. Y minus y1 is equal to mx minus x1. Remember, we said that we had it already updated. So we had the 0.27. So it's y minus 7 is equal to m and then x minus 2. But we now know that m is 3. So we can now plug this in. So y minus 7 is equal to 3, x minus 2. And then therefore we expand, because remember the question asks us to give it in the form y equals mx plus c, right? So if y minus 7 is equal to 3x minus 6, and so therefore we have y is equal to 3x. And then if I add that 7 on, it's going to be y equals 3x plus 1. This is our answer here. Does that make sense, guys? Yeah. So just to clarify, whenever you see that word tangent, guys, in A-level maths, differentiate. Even if you don't know what to do, tangent is just a key word for differentiate. It's just a synonym. If you ever see the word tangent, you differentiate because they're looking for the gradient, right? Okay, so we've done that. Now, this was the next one here, right? It says that the point Q also lies on C, right? And it says, given that the tangent to C at Q is perpendicular to the tangent to C at P, show that the x coordinate of Q is a third bracket 2 plus root 6. So this one is a little bit weird with the way they've written it, but all you have to do is just break it down, yeah? So for me, when I look at this, it says, given that the tangent to C at Q, right? So what does this mean? For me, this is a gradient, isn't it? This is the gradient at Q, right? Well, what do we know about this? Apparently, this gradient at Q is perpendicular, right, to the tangent at C, the tangent to C at P, right? So we have a gradient of Q that we don't know, but apparently what we do know about it is that it's perpendicular to the tangent to C at P. Now, remember, all of these questions at A-level maths is always in parts. You're most likely going to be using things that you've done before, right? Now, they're saying that the tangent to C is perpendicular to the tangent to C at P, right? Well, we know the tangent to C at P. The gradient of the tangent to C at P was what we calculated here, isn't it? Right? Does that make sense, guys? This here is just m is equal to 3 because that's what we calculated. We all happy with this? Gotta before I continue. We okay? Yeah, good stuff. All right. Now, if the tangent to C at Q is perpendicular to the tangent to C at P, are we able to figure out what this gradient is then? Yeah, we can. How so? Exactly. Thank you very much, Biana. If it's perpendicular, thank you very much, Nelio. We know that that means it's the negative reciprocal. So the tangent to C at Q, the gradient of it is definitely minus 1 over 3. Yeah? Okay. So that's a good step, right? You'll definitely get a mark for that. Now it says show that the x coordinate of Q is that there, right? Now, remember how dy dx works, right? We have a formula. Where was our dy dx? It was right here. I'm going to copy this here, right? Remember what the context of this formula does. You have you have an original function, you differentiate it, and then you get a formula which tells you the gradient at any point, right? So what we did beforehand is, remember, we plugged in x is equal to 2. When we plugged in x is equal to 2, this gave you a gradient of 3, right? That was what we did in part B, yeah? If I plugged in another value, let's say if I plugged in x is equal to 0, right? If I plug in x equals 0, then that will just be -1. Yeah. So the gradient at, for example, x equals 2 was 3. The gradient at x equals 0 is -1. Yeah. Well, what we know is that the gradient at this point Q is -1 over 3. Yeah. So remember what I say. You plug in values of x and you get a certain gradient out. Since we know that the gradient is minus a third of this tangent to C at Q, right? Do we then agree that then, well, for a certain value of x, right? If I plug in a certain value of x, right, this must equal that gradient of -1 over 3. Does this make sense, guys? This is very, very important. This is the key to this question here. Yeah, that there's going to be some value of x that when I plug it in, I'm going to get minus a third out. Does that make sense? This is the important part of this part C. Are we all happy with this? Yeah, good stuff. Now, the question said that we need to show that the x coordinate of Q is that, right? Well, that just means we just need to find x in this equation. Just move this down a bit because I'm running out of room. So now this isn't too bad though, because here we just need to solve this equation. Now this is a quadratic, isn't it? So if I move the minus a third to the right, to the left, sorry, it's going to be plus a third here is equal to 0. And then 3x squared minus 4x. And then minus a third plus 1/3. That's going to be minus 3 over 3. That's going to be minus 2 over 3, isn't it? Yeah. And then this is a quadratic here. What you can do, remember, you have a calculator, so you can just plug this in straight away into your quadratic solver. Or you could just times this by 3 just to make it a little bit neater to get rid of that division of 3. So 9x squared minus 12x minus 2 is equal to 0, right? And you don't even need to use the quadratic formula. You don't need to complete the square. You don't need to do anything. You don't even need to factorize. You could just plug it into your quadratic equation here, your quadratic solver in your calculator. So put this as 2, and then we just plug in the values. This here, we've got minus 12 like this, and then we've got minus 2 here. This gives us x is equal to 2 plus root 6 over 3, right? And if I click it again, this gives us the other one. Or x is equal to 2 minus root 6 over 3. Yeah? Now, if you go back to the question, right, it said a third 2 plus root 6. And that is just the same thing as that, isn't it? Right? So this is definitely correct. Now, we do get another answer, 2 minus root 6. But in the beginning of the question, they did tell us, right? Where is it? They told us that x was greater than 0. Yeah? So therefore it has to be this one. And if you can always just double check as well. If you plug this into your calculator, this will give you a negative number. Yeah. So this is less than 0. So we can't use this. So therefore it's this one. Does that make sense, guys? Yeah. Just gonna zoom. Let me just zoom out so you can see all the working for this one. We all happy with this? Yeah, good stuff. Okay. We've got one more. We're gonna overrun slightly. So apologies, but we've just got one.